Rewriting formulas. A formula is a type of literal equation, and a literal equation is an equation with two or more variables. So when you want to solve for one of the variables, you'll use inverse operations. So here's an example where we're asked to solve for z, and our formula here is capital H equals 1/4 z. So before we get into solving for z, a couple key notes is, if you have an uppercase letter in your formula, when you rewrite the formula, it needs to stay as an uppercase. If it's lowercase, it needs to stay as a lowercase. So two key notes is, the case of letter matters when you're rewriting formulas. Now in this case, I want to get z by itself, and I have a fraction attached to the variable. Now when you have a fraction attached to a variable, to get the variable by itself, you need to multiply by the inverse or the reciprocal of that fraction. So when I have 1/4, the reciprocal would be 4/1, which is simply 4. So when I multiply here, I'm going to be multiplying both sides by 4 to isolate z. Now keep in mind that when you multiply a number to a variable, the number needs to go in front of the variable because it's in a coefficient, and coefficients are in front. So our new formula here for z would equal 4 times capital H, or 4 capital H. This next example is our distance formula, where distance equals rate times time. I'm asked to solve for t. In order to solve for t, I need to remove that r. And when an r, or when that variable is attached to the variable, that is multiplication, so the inverse operation here would be division. So I'm going to divide both sides by that r to isolate that t and get my new formula. So t will equal d divided by r. This next example, we're asked to solve for h, and we have a couple things going on here. I have a fraction and a variable attached to h. So whenever you have a fraction being multiplied to the variable, you want to remove that first by multiplying both sides by reciprocal. Now in this case, the reciprocal of the fraction would be 2/1, which is simply 2. So the first thing we're going to do is multiply both sides by 2 to remove that fraction. Now remember that 2 needs to go in front of that capital H because it's a coefficient. So now we get 2 capital A equals BH. Now I want to remove that B. B is attached to H, which is multiplication. The inverse operation would be division. So we're going to divide both sides by that B, lowercase b, and we'll get our new formula for H. H will equal 2 capital A divided by B. Pause and try. So in this case, we're dividing both sides by capital A, and our new formula for X would equal capital BY divided by capital A. Pause and try. So we want to remove that 1/3 first by multiplying by the reciprocal, which would be 3/1, or simply 3. That will cancel out our fraction, giving us 3 capital B equals QS. And now we're going to divide through by S, so we can get our Q formula will equal 3 capital B divided by S. This next example, we have y equals x plus 3, and we're asked to solve for x. So in order to solve for x, I need to get rid of the plus 3 by doing the inverse operation. So the inverse operation of addition is subtraction. So we're going to subtract 3 from both sides. Now be careful here, because when we're doing literal equations or rewriting formulas, when we have subtraction, you want to make sure that it is written as subtraction. So I'm not taking a -3 and attaching it to y, because that would be multiplication. So what we have here is we're simply writing the y minus 3 horizontally versus vertically. So our formula for x will equal y minus 3. This next example, we have y equals x minus a, and we're asked to solve for x. Well, I have to do the inverse operation of minus a, which would be plus a. Again, you want to make sure that you write your formula so that it's y plus a, not attaching that a to y, because that would be multiplication. So our new formula for x would equal y plus a. This next one, you have to be careful here. We're asked to solve for x, and I have 5 minus x, and I want to remove that 5 first. Well, 5 is positive, so you have to subtract 5 from both sides first. So when you subtract 5 from both sides, you get y minus 5 equals a negative x. Well, when you have a negative sign attached to the variable, we need to remove that. And really what we have is a coefficient of a negative 1. And when it's attached, the inverse operation would be division. So in this case, I would need to divide everything by a negative 1 to remove that negative with that variable x. So be careful here, because when you divide by a negative, you're changing the signs of everything. So that positive y turns into a negative y, and that minus 5 turns into a plus 5. So be careful when you divide through by a negative 1. Pause and try. So in this case, I'm adding b to both sides. My new formula for x would equal y plus b. Pause and try. So I'm solving for x here. I need to add b to both sides. I get y plus b equals x. Pause and try. I'm subtracting 5 from both sides. I end up getting x equals y minus 5. Pause and try. I need to first subtract s from both sides. I get q minus s equals negative r, and I need to divide through by that negative 1 to remove that negative with the r, and my new formula will be r equals a negative q plus r, or plus s, excuse me. Now you see we are solving for x, and I have a two-step process to get x by itself. I have something attached to x, and I have a plus b with x. So in order to solve for x in this case, we need to first remove the plus. And in order to remove the plus, the inverse operation would be subtraction. So be careful here, because when we do subtraction, we're going to end up with ax equals c minus b. Now I need to remove that a that's attached to x, which would be division. And when you divide, be very careful. You need to make sure that that division line goes all the way across the c minus b, because the c minus b is being divided by the a. So everything needs to be over the a. So your new formula would look like this. X equals c minus b all over a. So that division symbol needs to go all the way across. Pause and try. So again, you're subtracting b here. We're going to divide through by m. My new formula for x would equal y minus b all over m. This next example is the perimeter formula for a rectangle, and we're asked to solve for w, or capital W. So in order to solve for capital W, we need to get rid of the 2L first. 2L is not attached to the W, therefore when I move it to the other side, the inverse operation would be subtraction. So you want to make sure that you know what the inverse operation is. And in this case, it's not attached to the W, and because it's not attached, we're either adding or subtracting, and we're adding, so we're going to end up doing the inverse of addition, which is subtraction. So I subtract it from both sides. That's going to remove that from the side where the W is and put it to the P side. Now I end up with P minus the 2L equals 2W. Now I need to remove the 2 that's attached to the W, and that is multiplication, so the inverse operation would be division. make sure that you divide the entire side, the capital P minus 2 capital L, by the 2 so that you have the correct formula. So our formula for W will equal capital P minus 2L all over 2. You cannot reduce the 2 on the top with the 2 on the bottom because it is going into both the P minus 2L, not just the 2L. So be very careful not to reduce the 2's in this case. Pause and try. So the first thing you're doing here is subtracting 2x from both sides, and then you're going to divide through by 3. So your new formula for y would equal 7 minus 2x all over 3. This next example is we're solving for y, and notice that we have y on the top where we have the whole expression on top being divided by 3. So when we're working with an expression and we have a division that's being divided into that expression, you have to first remove that division. So when we're removing the division, we're doing the inverse operation, which is multiplication. So I'm going to multiply both sides by 3. Now remember, when you multiply a variable by a number, you want to put the number in front of the variable. So we end up getting this by plus 2 equals 3c. So now that I have the expression, I can solve for y. To solve for y, the first move I need to do is get rid of the addition of 2, and the inverse would be subtraction. So I end up getting by equals 3c minus 2. And now I will remove the b. It's being multiplied to y, so the inverse operation would be division. So my new formula for y would equal 3c minus 2 all divided by b. Pause and try. So the first thing you want to do is multiply both sides by 3, and we end up getting 4f minus 5 equals 3k. And then you're going to add 5 to both sides. We get 4f equals 3k plus 5. And then you'll divide everything by 4, and your new formula for f would equal 3k plus 5 all over 4. So this next example, we're asked to solve for v, and you notice here that v is being divided into m. And in order to solve for a variable, you need it to be on top. So in this case, the first thing we need to do is get the v to be in the top position. Well, to do that, you're going to multiply both sides by v, because that's the opposite of division. So we're going to multiply both sides by the v, and we're going to end up getting vd equals the lowercase m. Now I can solve for v, and to solve for v, I'm going to divide both sides by that capital D. So my new formula here would equal capital V equals the m divided by capital D. Pause and try. So in this case, I'm multiplying both sides by the b first, and then we're going to divide both sides by r. Our new formula for b would equal 3 divided by r. So this next example, we're solving for lowercase b, and it's a multi-step example. So I want to solve for lowercase b, and it's inside the parentheses. So the first thing I want to do is remove everything from the outside of the parentheses. So I'm going to first work with that fraction, and I want to remove that fraction, and to remove that fraction, I'm going to multiply everything by the reciprocal. So 1/2, the reciprocal would be 2 over 1, which is simply 2. So that will remove that fraction, and I'm going to end up with 2 capital A equals h times parentheses capital B plus lowercase b. Now, there's more than one way to do this. You could use the distributive property, or you can simply divide both sides by h and then get rid of the parentheses. So there's more than one way to do this. Now the way that I chose to do it was to divide both sides by that h. that will remove that h, and I will end up having the 2 capital A divided by h equals capital B plus lowercase b. So that will remove that lowercase h from that parentheses, and when that is removed, we no longer have the distributive property. Now to solve for lowercase b, I would subtract that capital B from both sides, and I would get my new formula for lowercase b would equal 2 capital A divided by h minus capital B. Pause and try. So in this case, I chose to do the distributive property with that pt. I multiply the pt to the 1, which gives me pt, and I multiply the pt to the r, which gives me ptr. And then I'm going to solve for r by first subtracting the pt, and I get a minus pt equals the ptr, and then I'll divide everything by the pt to get r by itself. Now don't cancel out those PTs, because PT is being divided into the A minus the PT. So you can't just reduce those two PTs there. So the new formula would equal A minus the PT all over PT. Another way that you could have chose to do this is to first divide everything by that PT. If you chose to do that first, then you would end up with A divided by PT equals the 1 plus R. And now you would subtract 1 from both sides, and you would get R equals A divided by PT minus 1. So both of these solutions would be correct. So there's more than one way to solve a formula. Working with interval notation. An inequality is like an equation, but instead of an equal sign, it will have one of these signs. So inequality symbols, we have the less than sign and the less than or equal to. So the difference between less than and less than or equal to is that with a less than, it does not include the number, and the less than or equal to, it is less than, but it also includes the number. Similar with the greater than and greater than or equal to. So the greater than will not include the number. The greater than or equal to will also include the number. So that's important. The difference between the less than or equal to, greater than or equal to. So one way that we see inequalities is set building notations, where we have a variable, a condition, and the condition will be an inequality. So what this set building notation would look like would be something similar to this. And what it's saying is that in the blue part is my set of x's. So the set of x's, and that bar just means such that, and it gives a description of what my variable would be. So in this case, for my variable x, my x's will be greater than or equal to 5, which means that x is going to be 5, 6, 6.7, so on. So it's every value that is greater than or equal to 5. So you might see an inequality in set building notation. So it's important to understand how to read it. When we graph inequalities, there are two different ways that you might see it graphed. One way will be with endpoints. When you're graphing on a number line, if you have a less than and the variable's on the left-hand side, you would have an open circle of where the number is that the variable is less than, and then you would shade to the left. If you have a less than or equal to, the difference in the graph, you would close the circle, and that closed circle represents that it also equals that number. And then similar for the greater than and greater than or equal to is at a greater than you would have an open circle and you would shade to the left, indicating that it's increasingly getting larger. And if it's greater than or equal to, you would have a closed circle shaded to the left to indicate that it also includes the number. Another way that we're going to see the graphing of inequalities is in interval notation. So when we talk about interval notation and the graph for an inequality, it uses parentheses and brackets to graph our inequality. So if we have a less than, instead of using an open circle on our graph, we'll use an open parentheses to indicate that it's less than but does not include the number. When we have a less than or equal to indicate that it includes in interval notation, you'll use a bracket to include the number that it's less than or equal to. And then with the greater than or equal to, if it's just greater than, you have an open parentheses, and notice the direction of the parentheses will be open in the direction you'll be shading. So it's important that you write the parentheses correctly, and then if you have the greater than or equal to, you'll be using a bracket instead of the closed circle, and the bracket will go in the direction of the shading. So you'll be shading to the right. So let's see what this looks like. So when we're writing interval notation based on an interval, an inequality, and we have less than or greater than, when you're writing the interval notation with just the less than or greater than, you'll be using parentheses for the interval notation. And the interval notation always has to be written from smallest value to largest value. And the difference in the interval notation when you have a greater than or equal to and a less than or equal to is you'll use a bracket in the interval notation. So if it has the equal to sign, you use brackets, and again, you always want to write from smallest value to largest. So when we're talking about infinity, there is a sign for infinity, and you want to make sure that when you're writing interval notation that you use the symbol, and it always has a parentheses. And the reason why it has a parentheses is because an infinity goes off indefinitely and you can't close it in. Brackets close it in, but parentheses keep it open, so it goes on indefinitely. So whenever there's an infinity in your interval notation, you need to leave a parentheses with it. So we're going to start off by looking at a number line and understanding how number line works. So again, we have 0, and to the right is positive values and to the left are negative. Keeping in mind that when we have a number line and to the left is negative, it goes off indefinitely to negative infinity. So when we have the number line and we have something going shaded to the left and it's going off indefinitely, it's going off to negative infinity. If we have an interval or an inequality and it's shaded to the right, it's going off indefinitely in the positive direction or positive infinity. So being able to identify this on the number line is important, because when you're graphing an inequality and you have the graph of an inequality, you'll write your interval notation by looking at the graph, knowing that when you go to the left indefinitely, it's going to be negative infinity, and going to the right indefinitely, it would be positive infinity. So if I were to write my all real numbers, and all real numbers indicates that every number on the number line is my solution, well, to write it in interval notation, you'll be using the parentheses, because you always use parentheses for infinity. So parentheses negative infinity comma positive infinity parentheses would indicate all real numbers. So this is interval notation for all real numbers. Now if I want to write interval notation for a set notation where I have all my x values are x were less than 2, the first thing we're going to do here is graph this interval. So when I graph this, remember at 2, because we don't have the equal to sign, we'll be using a parentheses, an open parentheses, and it's open in the direction we're shading, and we're shading to the left because it's less than 2, so it's going to get smaller and smaller and smaller. Now I'm looking at the graph, I can write my interval notation. Remember, if it's going to the left indefinitely, it's going off to negative infinity. So if I want to write this as interval notation, it's going to go from a negative infinity, it's starting at negative infinity, and then it's going to end at 2. This interval notation represents x less than 2. So notice here, again, it always has to go from smallest to largest, and negative infinity is the smallest value here, and my largest value would be 2. This next example, we have a set building notation where my x is greater than or equal to 2. So now when x is greater than or equal to 2, again, I'm going to graph this, and at 2, because it's greater than or equal to, I'm going to use a bracket. That bracket indicates that it also includes 2, because that equal to. And we're shading to the right because it's greater than. It's going to get larger and larger. And remember, when it keeps on going indefinitely in the positive direction, we have positive infinity. So when I want to write this interval notation, I'm starting it with the smallest value, and the smallest value is going to be that 2, and it's going to increase indefinitely to positive infinity. So the interval notation, you're going to have a bracket around 2 because it includes it, because it's equal to, and it gradually gets larger and larger, so it's going to go from 2 comma to positive infinity. And again, you always use parentheses for infinity because you can't close it in. This next example, we have x is less than or equal to 2. So the difference between x is less than 2 and less than or equal to 2 is the bracket. So we have a bracket at 2 to include it, and we're shading to the left. And again, it's going off to negative infinity. Negative infinity is the smallest value. So when I write my interval notation, it's going to be parentheses negative infinity comma 2 with a bracket because we're also including that 2. So it's very important when you're writing your interval notation to use the right symbols. And this last example here, we have a set building notation where x is greater than 2. So because it's not equal to 2, it's just greater than, we're going to have an open parentheses, open in the direction that we're shading, and it's going off to positive infinity. So when I write my set builder my interval notation, we're going to end up having parentheses 2 going off to positive infinity, and we have end parentheses. So parentheses because it's not including 2, and it's going off indefinitely in the positive direction. So this would be my interval notation. Pause and try. So again, if you graph this, you see that it's going to be an open parentheses going off in the positive direction, and my interval notation would be parentheses negative 7 comma infinity with a parentheses.